Hello students, I wanted to do a quick practice problem for you with osmotic pressure because we didn't get to finish this one in class. So the example we have is with hemoglobin, and we've dissolved 35 grams of hemoglobin in enough water to make 1 liter of solution. And we measure our osmotic pressure, and we find it to be 136 millimeters of water, which is the same as 10 millimeters of mercury. And our temperature is 25 degrees Celsius. And we want to know what is the molar mass of our hemoglobin. So we're going to use our equation for osmotic pressure, pi equals mRT, to calculate m, which is the molarity. And then we can use the mass that we have per volume and compare it to our moles per volume to get our molar mass. Essentially, molar mass is just grams per mole. So if we know the grams and we know the moles, we can find the molar mass. So the first thing that we want to do is we want to make sure that we have everything in the right units. And this is largely determined by our R, which is 0.08206 liter atmospheres per mole Kelvin. And so we're going to want to make sure that we have everything in the right units. We've got liters for our volume, and our atmospheres we don't have, we have millimeters of mercury. So we want to turn this into atmospheres. 760 millimeters of mercury in 1 atmosphere is our conversion factor. That's just on your equation sheet for units of pressure. And this will turn out to be 0.0132 atmospheres. And now our temperature is in Celsius. We'll want to add on 273 to get our 298.15 Kelvin, which will be our temperature. So now we have liters, atmospheres, Kelvin, and we're going to end up finding the number of moles. So we can rearrange our equation. Molarity equals pi over RT. We measured our osmotic pressure, and it was 0.0132 atmospheres. We've got our R, liter atmospheres per mole Kelvin. And we've got our T, 298.15 Kelvin. And so the molarity that we'll calculate is 5.38 times 10 to the minus 4 moles per liter. So now the last thing is, we know that we started with 35 grams, and that was in our 1 liter. And we know that if we had 1 liter, based on our concentration here, if we had 1 liter, we know there would be 5.38 times 10 to the minus 4 moles. So grams per mole gives us our molar mass, which is 6.51 times 10 to the 4th grams per mole, or 65,000 grams per mole. And this is a sort of normal mass for a protein. So hemoglobin's a protein, and that makes sense as an answer. So this is just an example of how to solve a problem related to osmotic pressure. A couple of things to watch out for are the units. Always make sure that you have everything in the right units that you need. And one thing that osmotic pressure is commonly used to find is actually the molar mass of a substance, like a protein that's dissolved in blood. Okay, thanks.